branches and Littleman computer. The Littleman computer only makes use of a limited set of instructions, and if it were a real processor, it would be known as a reduced instruction set processor. But just like all the other assembly languages, it doesn't make use of selection or iteration statements. Now, normally, in the LMC, instructions will just happen one after the other in sequence. But we can use branches to control the flow of execution. So let's start off by looking at the code that flips a 1 to a 0 or a 0 to a 1. Now, if we have 0 as an input, then this if statement means it will output a 1. And if we have a 1 as the input, the else statement means it will output a 0. Okay, let's have a look at the code that does the same thing in LMC, and here we need to use branches and labels to create the same functionality. So to start, let's go through using a 0, and we're going to show the value in the accumulator. So the inp command is going to take the input 0 and store it in the accumulator register, or ACC. Then we get to the first branch, BRZ, or branch if 0. Now this is going to do a basic test. Is the value in the ACC 0? If it is, then it's going to jump to the label output 1. Now on this line, the LDA instruction is going to load the mailbox 1 into the ACC. Then the out instruction will output the contents of the ACC, which is 1, and the HLT instruction stops the simulation. So we started off with the input 0, and using the branch if 0 instruction, we've managed to output a 1. Now, if we use a 1 as the input, branch if 0 won't do anything, because it's not a 0, so we move on to the next instruction. This load instruction will load the contents of the mailbox labelled 0 into the ACC. The next line has the instruction BRA, which is an unconditional branch. So it doesn't matter what's in the ACC, it's going to jump to the label. So we're going to jump to line 6, where the out function will output the value in the ACC. So now we get the output 0, and then HLT stops the simulation. So we've used 2 branches so far, BRZ, or branch if 0, and BRA, or an unconditional branch. But there is a third one, BRP, or branch if positive. So let's have a look at another piece of code. Now this piece of code is going to output the numbers 1 to 10, and it's the while statement that has the condition to test. Is x less than or equal to 10? Now to do this in LMC, we need to manipulate it so this condition matches either branch if 0 or branch if positive. So let's just hide that and bring up the code for the LMC that does the same thing. Now we're going to want to keep track of the data in the mailbox labelled count as well as the ACC, so I'm going to put a box around it. The LDA instruction loads the contents of the mailbox 1 into the ACC. The STA instruction stores the contents of the ACC in the mailbox labelled count, which updates from 0 to 1. The value of the ACC is then output. Then, the value in count is loaded into the ACC, which doesn't actually change the value on this first time through. The contents of the mailbox 1 is added to it. So, we're adding 1 to the count, and then its output. The contents of the ACC is then stored in the mailbox labelled count again. Next, we subtract 10 from the ACC, and now we get to the branches. BRP is branch if positive. If it is, we'll jump to the label end loop, but because we're on -8, we move to the next instruction, which is the unconditional branch, and will jump us back to this label. And then we keep going, so we load count into the ACC, add 1, output, and then store the value in count. Subtract 10, and then the branches. We're still negative, so it loops again. If we keep going, then eventually the count will get to 10. We'll subtract 10 to give us 0, which will be treated as a positive number. So, when it gets to the branch if positive, it will jump to the label end loop and stop the simulation. And, if you're wondering, yes, branch if 0 would work here as well. So there we go. There are 3 branches that can be used in the LMC. Branch if 0, branch unconditionally, and branch if positive. And we can do selection and iteration using these branch commands, because we can manipulate any condition into using branch if positive or branch if 0.